Okay, I think we can start. Welcome to my talk about archunit. If you have been to the keynote this morning, then you have probably heard about archunit as the basement of the new project called Spring Modulith. And I want to show you what is this small framework doing and how you can use it in your own projects. It's basically about two topics that have nothing in common at first sight, especially architecture and unit tests. My name is Roland. I'm an independent consultant and I help software teams to bring their Java legacy systems into the future and, for example, untangling all their spaghetti code. And when I started creating this talk, I was thinking, how can you start a talk about software architecture? And I saw on my desk a small quote on my calendar which said, whoever wishes to build high towers must spend much time near their foundation. It's a quote from the Austrian composer Anton Bruckner, which, by the way, is this year his 200th birthday. So if you have the chance to listen to Bruckner's music, you should do it. And when I saw this quote, I was thinking, yeah, that's a good start for a talk about software architecture. Because what happens when you don't spend much time with the foundation? Well, you can look at the Leaning Tower of Pisa. Obviously, they didn't spend much time with the foundation. Well, they built a fundament, but it was on a very soft ground, and the tower started to lean, and they tried to fix this by building the other levels a bit in the other direction, and yeah, we would say that was a quick fix. But basically they built it on top of a very soft ground, which basically was the first software architecture. And because it was not well planned, they had to cancel the project, and the tower is not as high as it was planned. But let's talk about software architecture. When I come to teams, sometimes I see software architectures like this. Basically the foundation is typically a layered architecture with true strong layers, but then it starts getting risky with a small layer not really well integrated here, and these high towers will sooner or later collapse. Or another software architecture I see in several teams is something like this, where all the system is based on some temporary hack. And yeah, basically these are some projects which were built from a prototype, where a prototype was shipped into production. And I think you know the difference between a real project and a prototype. With prototypes, you don't write tests, right? And you don't structure them well. And if such a prototype goes into production, sooner or later also this thing will collapse. But with software architecture, usually we plan our software, we write documentation, we draw diagrams with arrows and boxes, and we write documentation how to build the system, how to implement modules. And when I see this documentation, I think I don't want to read this whole thing to start implementing in a team or helping a team, because when I read the first pages and when I come to the end, I forgot what was on the first page. And the thing is, when we change code, we still have to check if the code base still matches what was written in the documentation. And for me, I will forget about everything what's written in there. It's outdated, and the thing is, sooner or later, the architecture that we described and the code that we implement somehow will diverge, and the documentation, nobody reads it, and we don't check with every code change if it still matches the architecture. So what is the solution? The solution is archunit, and You see here a short description directly from the page, and let's see what archunit is about. First of all, I get this question a lot of times. Archunit, yes, it's a free library, and you can use it in every Java project, basically. It's all about checking the architecture of your Java code. Architecture, for example, could mean we have this layered architecture where we have a controller layer and we have a service layer and where we have a persistence layer, and the calls should go from one level to another or from one layer to another, from the controller layer to the service layer and from the service layer to the persistence layer, but not the other way around, and we don't want to skip layers. That's, for example, a use case where you can use archunit. We can use archunit with any Java unit testing framework, for example, with archunit, with Spock, with TestNG, whatever there is in the Java ecosystems. You can also use it in a simple main method to explore your Java architecture. Archunit itself provides integration directly with JUnit, for example, so it's getting easier to write archunit tests. We will see that in a minute. Basically, archunit is about checking dependencies between code units. Code units could be classes, could be packages, could be methods, could be technical layers, could be vertical slices about domain modules. For example, if we have 3 domain modules, a module 1, a module 2, and a module 3, then we can, for example, check module 1 calls module 3 and module 2, and module 2 depends on module 3. Oh, and what is this? Module 3 also depends on module 1, and welcome in the circular dependencies. And with archunit, you can prevent all these circles by validating that your architecture is free of cycles. And how does archunit work in the background? It analyzes all the Java bytecode, so it works on the compiled classes, and everything that's present in the Java bytecode can also be analyzed and validated with archunit. Archunit analyzes all your application into an object structure with Java class and all the members, the fields. We have here the constructors and all the field accesses and method calls and so on and so on. And we can define rules, architectural rules or constraints, and archunit checks if the application has violations for these rules. But enough with the slides. Let's go directly in the code. And if you have questions, use the conference app to ask questions, and I will try to answer them directly or afterwards after the talk. Let's go to our favorite project, the Spring Pet Clinic. And let's do this a bit bigger, presentation mode. And I prepared a small structure here, and when we explore the Spring Pet Clinic, for example, if we look into one of these components or modules, then we can see, just by looking at the class names, we can identify the roles of each class based on their name. For example, if I look into the owner controller, I would assume that this is a controller. And there it is, the controller annotation. So it looks like this is somehow an architectural rule that we could write arc tests, that we have an arc controller naming. Let's make this bigger. And then we can, for example, write as a new rule classes that are annotated with annotated with the controller annotation, that are annotated with controller, should have a name ending with controller. Simple, right? Let's run this for a moment. Come on, IntelliJ. should be faster. Okay, and we see a green test, which is good starting point. Okay, let's assume we get a new junior developer to our team, and he tries to add a new controller, and somewhat he doesn't read the documentation, and he creates a demo endpoint and said this is a controller. And now I hope we get a failing tests. Yeah, I love failing tests. And it's also good to validate that your tests fail, so that you can have confidence that your tests actually test the right thing. And when I look into the error message here, it says classes that are annotated with controller should have simple name ending with controller. And it says the class demo endpoint does not have a name ending with controller. So we have a failing unit test, and we have the rule that was violated, and we have an indication what was wrong. And if you look closely into the error message, I hope it's visible in the last row, classes that are annotated with controller, classes that are annotated with controller. So basically archunit translates what we have written in the Fluent API here, translates directly into an error message once the rule fails somehow. Okay, let's go back to the demo endpoint and delete that for a moment so that the tests are still green. So very easy, right? Then the next thing we can do, the pet clinic itself, basically it has two domain modules. One is with the owners and their pets, and we have the vets that are working in this pet clinic. And if we look deeper into the code, we will see these modules are completely independent, so they should not have a dependency somehow. And we can write a new rule, for example, owner dependencies, and say classes that reside in a package something.owner.something. It's a special archunit syntax here to match packages based on their names somewhere in the hierarchy. Classes in the package should have simple name ending with owner is not correct. Should not depend. Oh, the Fluent API does not have a not depend. That's bad. But fortunately, everything that's here in the Fluent API can also be composed in your own way. For example, I could write should not depend on classes that reside in a package vet. So what I say in this rule is classes that are in the package owner should not depend on classes in the package vet. Let's add some points to match somewhere in the hierarchy. And let's break this test. For example, if some developer thinks, okay, the owner repository should have a new method, say, saying vet get favorite vet, something like that. So a new method in the owner package that returns a vet object, which is clearly an architectural violation here. Yeah, we were at the owner repository that now returns the favorite vet, but clearly it's an architecture violation where it says classes that reside package owner should not depend on classes and package vet. And it says the method owner repository get favorite vet has return type vet, which is an architectural violation here. Okay, let's remove that for a moment and go back to this one. Yeah, one question that appears also every time I give this talk is, I don't have one project where I can write the rules, but I have maybe hundreds of projects, and I want to have the rule in one central place, and all the projects should use the same rules. How can I get to this one? And let's assume these demo architecture tests here is a Java class somewhere in your company, which you can publish as a Maven artifact or something like that. And in your own demos, and in your own project, you can, for example, arc tests in demo architecture tests, and arc tests it is. And we can import all arc tests or arc rules that are defined in some other class. For example, we can write a class with all architectural rules for our technical layers or for our module dependencies or validating naming rules or something like that. And it should, I should say analyze classes. But you get the idea. I can provide a central class somewhere as artifact and import all tests from one class, and I have demo architecture tests controller naming and demo architecture's owner dependencies, for example. Then the next question that everyone wants or everyone asks is, I have a legacy project, and when I introduce archunit, I will have so many failing tests. How can I avoid that? Let's make an example. Let's say we want to have logging in our application. For example, we have a REST API here and want to say all methods that are annotated with post mapping, so every post request should log. So every request that changes our data or changes our system somehow should produce log messages. But archunit does not know what logging means. But we can define our own conditions. So it's a bit code to write, so I prepared it here. We can write our own condition that we can say what means logging. In this case, archunit will invoke our check method here with every method that is annotated with post mapping, and then we can say, does this method satisfy our condition or does it violate our condition? For example, in this case, I go through all method calls that this method has and check if there is any method called to a class from SLF4J logger. Pretty simple, right? And if there is no such method, then I will produce an error violation or architectural violation saying this method does not log. And let's see. I assume this test is failing. Yeah, because that's a rule I came up with, and obviously all post mapping methods fail. So in this case, there are 5 violations. If you are in a typical legacy project, you will have 500 violations. So, but the problem is a unit test only has 2 states. Either it's green and everything is okay, or it is red because at least one thing is, we have at least one violation. And the solution for archunit here is that we can freeze the current state and say, I know that we have several violations, but I will freeze them for a moment, and the test is green. And what archunit does in the background is it creates a file, a text file that we can check in our Git repository where all current or frozen violations are listed. All these methods here, process creation form, does not log. And then we can check in these tests with add archunit. Okay. And when we introduce a new post mapping method here, somewhere here, post mapping void the usual suspects, do something. When we add a new post mapping method, then the freezing sees, oh, there is a new violation that wasn't there before, so that it fails with exactly this one new violation. So I have to logger factory, what is it? Logger factory, get logger, this, I don't know, info, hello, and then we have the method call to a method that is defined in the logger class in SLF4J. The other way around, if we fix a violation that was frozen for example here, the process update owner form. Oh, there's missing this one. Then archunit sees, oh, a frozen violation was fixed, so it is removed from this text file. And so this is a way to reduce the technical debt step by step, but having the chance to not introduce new violations. So freezing is a great way to add archunit to legacy projects. What else do we have? Next question is typically, is there a library for predefined rules so that I don't have to repeat everything on my own? Okay, let's give them some space here and say, for example, there is archtest, no? Too much curly braces. Archtest, maybe we don't want to have calls to system out. We don't want to have system out print line. And archunit provides, for example, general coding rules. Standard, no classes should access standard streams. And this predefined rule, for example, identifies everything that's connected to system out, system error, system in, and eprint stack trace, for example, so everything that's connected to the standard streams. The next thing what archunit provides out of the box is, for example, archtest. If we have a layered architecture, then there is predefined architectural rules, for example, layered architecture, or because we had the question in the app, there's also onion architecture as predefined set of rules. But let's say we have a layered architecture here, considering only dependencies in defined layers. For example, we have a layer controller, which is defined by classes that are annotated with controller. And maybe we have a layer called persistence, and every class that is assignable to Spring data repository is part of the persistence layer. And then we can say, for example, layer controller may not be accessed by any other layer because Spring invokes our controller, and where layer persistence may only be accessed by layer controller. And that's it for our layered architecture. Pretty easy, right? Everything's green, that's good. And for example, if I go to the vet repository and say we want to have whatever wet controller do something, if the repository or if the persistence layer has a reference somehow to the controller layer, yeah, of course, Spring Data will complaining about that, but also archunit will now complain about that. And it says we have the rule that was defined, these layers and these accesses are allowed, but it says the wet repository do something method has a return type of type wet controller, which is not allowed. Okay. Other predefined rules. There is, for example, yeah, of course, Spring Modulith, which is basically integrating the architecture directly into your production code, or extracting, for example, documentation or verifying your application or architecture from your code. But another thing is archunit is great when it comes to basic Java, but there is room for improvement. For example, here we used post mapping, but basically post mapping is the same as request mapping with method equals post. And archunit will not does not know that these two different annotations are the same. For example, if we have the wet controller here, we don't have a get mapping. It's the same as request mapping with method get. That's the same. In plain Java, these are two different annotations, but in Spring, these are the same annotations. And therefore, I added or created a new open source library, which is the archunit-spring library. For example, that we can say not only annotated with controller or REST controller or my controller, so that we can say that are annotated with, that have the Spring annotation controller, which could be controller or REST controller, controller or REST controller. Because the great thing about Spring is you can create maintainable applications with this Spring annotation model, which is about composing annotations and meta annotations and these attribute aliases. So for example, if I create a new class which is a REST controller, this attribute Spring annotated with would also find this controller class. But archunit-spring has something more, because it also provides predefined rules. For example, let's say we have here in our controller somewhere a method get name for some ID and return hello, whatever, and bring it to the top. And for example, we have a method get display name for long ID, return get name ID dot display. And then we want to say, because we want to retrieve the name from the database and the database calls are expensive, we want to cache the name. And with the cacheable annotation in Spring framework, Spring intercepts or proxies all these calls to the getName method and will look into the cache if there's a value for these parameters, and if so, it will return the cache value, otherwise it invokes the real method. The problem with that is, IntelliJ also highlights it here, invocations from the same class are not proxied with this cacheable behavior. So it looks like the cache is used, but in fact it is not used. And for example, in the Spring archunit-spring library, there is, for example, a Spring caching rules that we can say cacheable methods should not be called from the same class because that would violate the proxy behavior. Okay, what else do we have? I think that's pretty much it. Let's go back to the slides. What we saw is that we have the usual challenge that our documentation we write the documentation, nobody wants to read the documentation, nobody wants to maintain the documentation, and we have the code on the other side that maybe follows the architecture, maybe does not follow the architecture, so these two will somehow diverge in the end. So why do we have the documentation anyway? With archunit, we have now the possibility to define our architectural rules in code, in unit test, and we have the unit test which we can run in our IDE, which we can run in our CI pipeline, and see that we do not ship violation or wrong structured code to production. And as we saw, the freezing mechanism is a great way to introduce archunit into legacy projects. As I showed, there is archunit-spring, which is a small library which has predefined archunit rules for Spring applications, for Spring Framework, Spring Boot, and with the Spring annotated with, it's getting easier to write custom rules. I gave this talk at another conference, and somehow I saw that some AI tried to summarize my talk about archunit, and the conclusion of the AI was, with archunit, the Leaning Tower of Pisa would not have happened. Okay, but on a more serious note, archunit is a great testing tool that you should have in your toolbox, and I would say give it a try. But as with every testing tool, it is that it cannot show you that everything is all right. It can only show you the errors. And yeah, that's basically it, what I prepared for you. If you have feedback, questions, or want to connect, use the conference app. You can find everything that I have shown on GitHub, for example, the archunit-spring library, some more examples, documentation. As I said, Spring Modulith is built on top of archunit. So if you want to build modulithic applications, take a look at Spring Modulith. And if you want to connect, feel free to come to me. And I think we have some time left for questions.
When I tried out Spring Modulith, and is there an integration between Spring Modulith and archunit? Because Spring Modulith already knows about like the packages and all that. So is it possible to define extra archunit rules based on the Spring Modulith scanning that already happens?
So the question is there an integration with archunit and Spring Modulith so that I can define custom archunit rules based on top what Spring Modulith analyzed or defines? I'm not sure. I have not tried it yet. So maybe yes, maybe no. More questions? So the question is, when I added the freezing method to freeze all the post mapping logging violations, and when I added the new post mapping method, then where did I edit this? Don't know anymore here. And when I remove that, for example, if I have and now another violation, what happens in here? And in this case, archunit will fail because it's not on the text file. Archunit itself will not add new violations into this file. You can add them manually if you don't want to fix them right now. But archunit does not touch this file to add new violations, but only remove these violations. So the freezing mechanism is a great tool to create to-do lists, basically. Very helpful in legacy projects. More questions? So the question was, is there a possibility to check if the number of frozen violations is getting smaller, right? Not built in, but you could use, for example, the bash with count line in the text file. And for example, put that into SonarQube also to check the metric how many frozen violations we have currently in here. More questions? I think the question was, is it possible to write these violations into a JSON file? Is that correct? The format of this violation file. I think you can implement your own violation handler, freezing violation handler, but I would have to look that into in the documentation. But the default is this text file, but maybe you can write your own somehow to parse this text file and give it into your own format.
So I understand these architectural tests are run against bytecodes, right?
Yeah, they are run against bytecode.
I don't need to necessarily have the test within my repository. Rather, I can extract them out and make a more generic, put them in a...
Yeah, for example, you can extract all these tests into a separate module, into a separate artifact, and include them, for example, as Maven dependency, and run these against your custom project so that these are separated.
Now I have two questions.
Mm-hmm.
One is, can I run these tests purely against the bytecodes? So I don't need to invoke them in my repository. Rather, I just add one more step to the workflow formatting and just run the tests without them even having any knowledge of it.
Yeah, the question was, can I run the tests only against the bytecode? This is where this one annotation is relevant. I skipped that for now because it says archunit, before you run the first test, please analyze these classes. And in this configuration, I said, for example, please analyze everything that's in the package where the pet clinic application is and do not include the tests. But let's say what else we have. You can also apply a location where it points to a jar file, and archunit will then look into this jar file and takes all the class files and will analyze them.
And in that case, how do you deal with the freezing rule? Because you don't have that repository.
How to deal with the freezing? Archunit itself will write the freezing or the frozen violations into the current working directory. If you don't configure something else, because you can configure the path and so, but that's written in the documentation. One question.
What are the disadvantages and what the limitations of archunit?
What are the disadvantages and limitations of archunit? First, the limitations. The limitation is it can only analyze what's in the bytecode. So some parts are not compiled from the source code into the bytecode. For example, if I have a public static final int default ID also 0, and I use this owner dot default ID here, then the Java compiler will inline this constant directly into the bytecode, and there is no reference to this field. This is one of the downsides of or the limitations of archunit. The disadvantage is you have to maintain the rules, but I think that's not a disadvantage because you have to maintain them somewhere, and in the documentation they are outdated. I guess there are disadvantages, but you have to think about what you want to write as rules, and maybe I think there are disadvantages, but I can't remember any now. The number of classes.
Let's say if you have 10,000 classes, so will it be linear when the amount of classes is growing, the execution time of the test?
Yeah, if we have, so the pet clinic itself, 20, 30 classes is really fast with maybe 1 second analyzing the classes, and as you can see, the following test only a few milliseconds because it only analyzes the classes once and reuses them. But what about project with 10,000 of classes? I think the analyzing of 10,000 classes maybe half a minute also once, and then also executing the rule is also fast, but it's not that the analyzing is hours or so. It's, I think 10,000 classes should be possible in half a minute, I would say.
If I'm doing some DB stuff and I have bounded contexts and I want to define the dependencies between those bounded contexts, is it possible to read this information from, let's say, plant unit diagrams or something like this?
The question is, can I read dependencies between modules from, for example, plant UML diagrams? Archunit has you covered. Let's say plant UML condition adhere to plant UML diagram. So you can read a plant UML diagram. Archunit will parse it into allowed dependencies or into archunit rules, and will check that the architecture in your code adheres to the plant UML diagram. Can you parameterize the tests? I want to answer this in a slightly different way, because what we see here with archtest annotation and analyze classes annotation, this is the integration for JUnit 5, where we have in JUnit 5, you know, the test annotation, and there we have here the archtest annotation. And as I said in the beginning, you can use archunit with every testing framework and also with main methods, for example. One thing that's possible in the archtest framework, that's archtest something, no, that I can have, for example, static void check, and archunit could, for example, inject all the analyzed classes that I can be or can write programmatic rules, for example, in the main method, in this test method, or I could write my own code somewhere, somehow. I do this in a main method for a moment, where I can say, I take the class file importer that is behind these analyzed classes and import package of pet clinic annotation. And what I do in this method here, either a test method or main method, you are completely free. Okay, I think the time is nearly up. Every question that's, oh, there are so many questions here. I will try to answer them afterwards. And yeah, I want you to try archunit. Maybe not today, listen to the other talks. Maybe not tomorrow, listen also to the other talks. But at least on Monday, you should try archunit. And if you have questions or want to more know, please come to me, talk to me, and enjoy the rest of the conference.